Hello, good morning, good afternoon, and good evening, wherever you are. Happy to have you again with us at Sumo Logic Illuminate 2020. This is Application Performance Management for Microservices session. My name is Pawel Brzoska, and I'm leading APM part of Sumo Logic platform from the product management perspective. Today, together with Norberto Kueffner, we're going to talk about how we're extending our best-in-class observability platform for distributed tracing and APM use cases. Since this topic may be news for many of you, I would like to start with an exciting announcement. Sumo Logic Observability Platform now fully supports application performance data from distributed tracing and deeply integrates with all open source tracing standards like OpenTelemetry, where we're one of the key contributors. This is just the beginning of more updates and additions coming soon that will address majority of your application performance related requirements from the browser to the database directly in Sumo Logic as a complete platform for overall observability needs. Just in case you're new to the concept, distributed tracing allows you to track execution of your users' transactions by following them between applications, microservices, and provide easy to understand visualizations of transaction lifespan with ability to pinpoint any slowdowns, errors, and responsible microservices. This data is natively ingested to the same Sumo Logic secure, scalable, and flexible backend that you enjoy today for log analytics and metrics monitoring. Allows us to deliver you the whole new set of use cases, from ability to aggregate the data to build dashboards, giving you visibility to microservices health, ability to correlate with infrastructure KPIs, and track application dependencies using flow diagrams or topology maps that we will be opening for beta soon, to single transaction search and troubleshooting with drill downs to logs and infrastructure KPIs that is part of the recently announced observability GA. We're fully supporting all open standards for tracing, emerging OpenTelemetry, as well as legacy open tracing and open census standards. If you have already adopted any of them, including projects like Jaeger or Zipkin, it is enough to change your exporter configuration to point at Sumo Logic open source collector and enjoy your tracing in the new UI inside of Sumo Logic. If you still did not adopt any of these tracing standards, it is very easy to start by attaching OpenTelemetry auto instrumentation already available for languages like Java, JavaScript, Node.js, Python, Ruby, .NET, or leveraging existing open tracing capabilities of service meshes that we also support out of the box. So some of you new to the topic might have a question: why would Sumo Logic rely on open source to collect application performance data? We've discussed this topic with many of you that already explored this area, and over 90% of you agree that this is the preferred way of collecting tracing data. Moreover, many already treat this as a hard requirement. You're tired of black box vendor-specific instrumentation that locks you in, slows your innovation, and dictates how you should build your application and how your monitoring data should look like. You want flexibility of producing telemetry the way you want. You want to retain visibility even if you introduce new language frameworks or polyglot services. And finally, you want to retain your precious instrumentation in case you want to send data to any other standard compatible backend. More and more organizations feel the same way, and that industry trend was recently confirmed also by leading analysts that predict that in a few years, half of the new microservice-based applications will use open source instrumentation instead of vendor-specific agents. Also, advising everyone to adopt OpenTelemetry as an emerging standard for tracing collection as soon as possible. With that, I would like to now invite you to see how we can use Sumo Logic Observability Platform to monitor and troubleshoot application performance problems with tracing data. This demo will use a combination of already released as well as soon beta-ready capabilities. Let's jump to the live demo platform. So let's log into Sumo Logic and access an example custom dashboard I have created to monitor my demo application stack. As we're able to see here, we are able to actually combine data from application services here in the top section with things like errors, load and latency for microservices with infrastructure KPIs coming from, for example, from KPIs like CPU or pod health from Kubernetes metrics and logs. And at the bottom, we actually have AWS Cloud Infrastructure metrics, all on one screen in context, providing top-down view of your application stack health. Going back to our services, this table shows all tracing instrumented services automatically with their KPIs in a form of a honeycomb or a table, but we can actually see the same information in the context of the dependencies and relations between services once we open the service map. So we can see all application service dependencies. I would like to focus on this particular application map where that is basically mimicking a coffee bar setup, where we have the coffee lover service calling a coffee bar that in turn calls coffee machine for beverage preparation, as well as cash desk for payment. If we're interested in more details about any of the services, we can drill down to open the service dashboard. Here in a standard out-of-the-box Explorer view that we can select from here, we can see the microservice health golden signals, latency, request, errors, also in form of time series. And we can also actually see a spike here, an outlier for the latency. So let's investigate the individual transactions that have been running through this microservice in that particular time during that spike. Let's click on that icon here to drill down to traces. Here we have the list of single transactions that were running across that service that we have selected here for filter for this particular time that we have selected. We see a few long-running transactions with the main contributor being the coffee machine service, and also some non-200 status indicating an error. So let's click one of them to investigate in more detail. This is the chart of execution of a single transaction. As we recall from the service map, we have a lover service calling the coffee bar, then the coffee machine, which prepares the coffee and water in these two small spans into which we can quickly zoom in here. We have a coffee here and we have a water preparation here. So what we can also see here is we can see all the spans with errors. So we have some spans with errors in the second thread here for the payment thread. So let's click on that and let's investigate that in a bit more details with status 402. So indeed there was an error. We can also immediately drill down and open logs for that particular span to understand what was wrong with that. As you can see, automatically filter only for the log lines that are pertaining to that particular span ID. And we can clearly see that the reason for the error was basically that the customer was not didn't have enough money to pay for the coffee. But let's go back and let's focus on the duration problem. As we can see from the critical path contribution here, we have these two particular spans, these two calls that are consuming the biggest amount of the end-to-end duration time for that particular trace, for that particular transaction. So let's investigate that in more details. Here we have all automatically collected metadata, and in the infrastructure tab, we actually have, we can see the infrastructure that this call has happened in. So we have information about the container, we have information about the pod, and as we can see, we have some spikes actually at the time when that transaction happened for the CPU and for the memory. So we see some abnormalities, and for the deployment, we also see that there is only one pod that is running, even despite of that, infrastructure KPI spikes. So it's definitely infrastructure that is at blame here, and we can also quickly check the logs to see all the logs from the container. That actually does not apply the filter for the trace ID. That basically gets you all the logs from that particular container, just in case you want to investigate. But I would like to propose to actually drill down to see a dashboard for the deployment just to prove the point that we can very quickly and very easily go back to check the infrastructure in case we're interested. We can expand it to 6 hours so we can learn more about behavior of the infrastructure. And yeah, we can see here everything we need really to understand all required information about architecture and behavior of the coffee machine infrastructure. We see a single pod running, we see spikes every hour. And again, as you could see on all the demos during this Illuminate session, this Illuminate event, we can click on that. And there's always that infrastructure that tab allows us to jump to other dashboards, to logs, back to traces, or to metrics. That is in overall end-to-end observability experience that we're delivering with that release. Seamless navigation and pivot between logs, metrics, and traces, everyone in a single platform, in a single UI, in a single observability product that can solve all your application reliability needs. That will be all for the demo. Let's go back to slides. A couple of other exciting capabilities we're working on and hoping to deliver soon is browser monitoring. You can see here at the top of the screen, the span of a trace actually comes directly from the browser. We have all the browser details here in the right side pane. As well as span analytics, allowing you to query your raw tracing data similar way you would analyze logs and create various types of analysis visualized in forms of charts or tables that you can pin to custom dashboards same way as with logs and metrics. Why would you consider Sumo Logic as your overall observability platform also for application performance use cases? We talk practitioner language. Traces are traces, spans are spans. This is hard, that requires additional analysis and a lot of hard work on the back end, but that's what we do. It is not a standalone product duct taped to the rest of the platform, but it's a natural extension of your existing use cases. It is open and flexible, scalable and secure, and offers same great integrated analytics that you already know for logs and metrics. Reminding our initial announcement about general availability of transaction tracing capabilities from the beginning of the presentation, I would also like to take an opportunity and invite you to participate in our early access program for early adopters for next upcoming APM capabilities demonstrated today as well. Service map, application service dashboards, and browser monitoring. If you're interested, reach out to your Sumo Logic account team or let us know by emailing us at tracingap@sumologic.com. Summarizing, we're extending Sumo Logic platform to cover application performance use cases. You can already now enjoy the value of distributed tracing directly in Sumo Logic by adopting free, flexible, and community-supported instrumentation standards, and fully adopt Sumo Logic as your observability platform of choice for end-to-end, top-down reliability needs of your application stack. If you want to start using the product right away or have more questions, we would like to invite you to our follow-up Illuminate sessions. We have the implementing distributed tracing workshop later today, as well as the Meet the Experts session where you can ask me questions. And in case you want to read a little bit more about the product, feel free to reach out to our online product documentation. And if you want to get in touch with us, the best way is to use our Sumo tracing channel on our Sumo Slack Sumo Dojo. Thanks for attention. Now I would like to ask one of our early adopter customers, Norberto Kueffner, leading Elementum site reliability engineering team, to share some of his experiences with Sumo Logic observability and distributed tracing. Norberto, please take it over.
Thank you, Pawel, for that great demo. It's awesome. Working with you this last couple of months was a great experience. All right. Hi, everyone. I'm Norberto. I work for Elementum. We are a small company. We provide the incident management application for managing supply chains. I would like to start by commenting out about our high-level architecture, which is quite complex by all means. We use a microservice architecture, and nowadays we use two different orchestrators or frameworks for supporting our deployments. One is DCOS and the other one is Kubernetes. Nowadays we move to EKS, so that's our platform. Besides that, we have multiple pipelines for ingesting customer data. That is shipping information, locations, points on maps, all sort of information to display on our application. And our application is multi-tenant. Basically, we have all our customers or enterprises residing on the same application as different tenants. So we have the necessity of signing each one of the calls we have on the platform and tracking everything a single user does for that company or for others company, because a single user could be working with more than a company, which is quite exhausting on the platform. That means we have to validate each of the signatures of each of the calls of each of the microservices supported by our orchestrator, which make tracing quite a big deal for us. So we had another vendor for tracing, and basically we had another vendor for APM and metrics. The issues we had with this vendor were mainly around bulky contracts. You all might know that the second largest bill you will have on your company is observability in all their forms. First is infrastructure, then it's observability. We had several different vendors for bringing observability into the platform. So we had multiple interfaces, multiple configurations among the different layers of our microservice architecture, among all of our different EC2 instances and all the infrastructure we were running. Another thing was double training for our developers. We had gaps. Maybe a developer knew how to do tracing, but had no idea how to check out on the infrastructure itself, or had no idea where to look for monitoring events and stuff like that. Quite hard for them. It was also hard to correlate tracing, logs, infrastructure, and issues in general. Doing troubleshooting was hard because we were jumping along with different vendors, different interfaces, different configurations. Not a good thing among the developers. And again, we had multiple agents, multiple things configured on all our Java services, on all our infrastructure had multiple things attached to it. And it was super easy for our DevOps team to make mistakes and, I don't know, unconfigure tracing for certain parts of the infrastructure, or misconfigure it, creating hordes of logs, ingesting into Sumo Logic, raising the costs. There were a lot of things to consider. So we heard about the upcoming beta for tracing in Sumo Logic, and we found something awesome. This is our brief, this is the brief of our experience with Sumo Logic. We started the conversations with Chad, who was our account manager. He introduced us to Pawel, then to other people, and we reached an agreement to join the beta program. A few tips and some guidelines along the way, and we had everything ready in 2 days. And then we began our proof of concept. The deployment of agents was pain-free, as it was with the log collectors from Sumo. We found some things that were simply great, like the usage of OpenTelemetry for collecting tracing events. most of the developers agree with this. Using OpenTelemetry, using an open-based collector for ingesting telemetry data is sexy, it's beautiful. In case we decide to move along with some other solution, or if we decide, I don't know, to swap vendor, it's the same collector. It's beautiful. We were able to send tracing on our proof of concept at the first try. The first try was the one. We were able to configure, as I said before, we were able to configure the collectors immediately, and we were sending tracing data in no time. Also, we included the collectors on our EKS cluster, and it automatically configured a new dashboard for everything, which was quite a good surprise. The spam visualization is also quite good. Basically, I will talk a little bit more about this later, but the developers found or saw the value immediately after seeing the level of integration that you were capable of bringing together. Just trace logs and infrastructure are 2 clicks away. Just jumping from a tracing event to a logging event to an infrastructure failure or bottlenecks, 2 clicks away. Everything is 2 clicks away nowadays. And again, Pawel has been great at rolling out new features and actually implementing things that we thought would be great. 1 week later, we had it. The experience so far has been great. I really and truly appreciate what Sumo Logic is doing. It's a game changer. That's what I truly believe, and everyone else at Elementum is thinking the same. It's simply wonderful. So the beta is finishing. We are waiting for the general availability of the features to go in all in with these features. We already contacted all of our other vendors providing traceability monitoring to shut down all the contracts. So the adoption, we are starting to roll out the capabilities of tracing and monitoring and, well, the EKS dashboards, which are great right now in our integration environment. One thing to highlight, analyzing the root cause of issues has become simpler and faster. Those are not my words, are developers' words. They are now finding root cause of integration issues or bottlenecks super fast and super easy than before. Before that, they will have to jump into 2 or 3 different providers. Right now, it's just point and click and follow the trace. It's amazing. And as we speak, we are preparing the rollout into our staging and production environments. Frankly, I have no doubt that this will be a success. Thank you very much for having me. It was a pleasure having this presentation. If you have any question, please, you can proceed to ask on the chat right now. Thank you very much. Bye.